Oh, so that's where
There's a lot of drinking going on around here.
Neil, not drinking anymore.
Okay.
Not
We're
drinking.
not drinking any less either.
I don't drink, that's the same better to funnel.
I haven't heard that forever.
All right. I'm Emil, KE5QKR, member of the Ozone Club since I've been a ham. And the club has awesome services here and people in the back office to make this stuff work for us. And one of the things they do is quite a few digital services. So my focus, ever since I've really been a ham, I've been in IT for 27 years. So I focus on digital. I have some coworkers here. And a lot of my focus into what I do is in digital data. But today, the agenda is going to be a couple of different aspects of digital modes and hams and what we do. Voice, data, networking, and my favorite part, the challenges of making this crap work for us.
Right, you're linking it?
Huh?
Linking it up?
Lincoln and people. It's a very important part to this, so you'll see it through the out. So first on the agenda is voice. We probably all dealt with some mode of digital voice, whether it was DMR, D-Star, C4FM, or Yaesu System Fusion, P25, Public Service Networks, NXDN, which is kind of a combination of Kenwood and ICOM and other vendors. We're coming up with other modes. M17, which is something relatively new in open source, because they're trying to get around the people who are selling big, expensive chip modes, and closed for development. So M17 is in open source. FreeDV, most of these were all primarily HF, UHF. However, some of them also work on HF. A lot of people don't know that. But FreeDV is one that was developed specifically for HF from a developer who was working with mariners for satellite communication, where the bandwidth is only 1 to 2K for using a codec that's also open source. Codec 2 it's called. And that's HF. Then there are analog. You know, somebody might ask, why am I putting this on digital voice? All-Star, Echo Link, and RLP, those are all analog modes. Well, you got to ship them over TCP/IP, which means something's got to digitize it, send it, serve it. VoIP protocols. You got it. They're going to send it over IP, the internet. So it's going to become digital at one point.
Okay.
All right. Then there is the Ham Shack hotline. Everybody ever heard of that?
Never heard of it.
I saw that.
SIP services, SIP phone services. Hams are setting up networks that are global, where you can just dial into their phone system.
Session information protocol.
You got it. It's initiated. A session initiated protocol, and what it'll do, it'll also bridge with RF. Repeaters are listening to conference servers that people are talking on. On SIP, hams over IP is another. Somebody started a new network already. So there's lots of new things in here. So we're going to start off going down this list on the voice side. Digital mobile radio, DMR, is probably one of the most popular, in my opinion. And I listed some pros and cons here. Don't throw tomatoes at me because this is subjective. You're going to find different people who say different things about the pros and cons. I think one of the pros are audio quality versus analog. Analog, you got bacon frying. You could have somebody out there on the fringe, and he's keying up, and you're not going to hear that unless he's got background noise, like a radio playing or something, which you're not supposed to do. But you also, you won't hear that air or the analog sizzle of the FM mode in the digital mode. You're just going to use voice and whatever's coming through that mic, even out to the fringe. Okay? And then, of course, when it gets past the fringe, you're not going to get nothing. It's either there or gone. So the quality, I'm not saying the signal quality, that's different. I'm saying the audio quality versus analog is different. Multiple time slots. Time division multiple access. Anybody ever notice if you listen to a DMR radio, you key it up, and it's pulsing? It's got this, if you ever listen to the radio, it's pulsing. Once it synchronizes with the repeater you're talking with, there are 2 available time slots. 2 conversations on the same frequency at the same time. Somebody's on time slot 1, somebody's on time slot 2. That's 2 different conversations that can happen on one repeater frequency. That's a very good thing for ham radio as far as people talking and listening to the reflectors and the rooms, the conference rooms that are out there. So it's a very functional mode. Another one is it's also an international standard. These things are global. The Brandmeister network spans the globe. The entire planet is talking on this mode. And you can connect to them and link to them, like you said. That's another part of this presentation, networking. They have established networks. That's a pro. Brandmeister, TGIF, any others? I don't know of any others.
EMR Mark, I think.
Mark, net, okay. There are portable and mobile models. I have not seen many base models using DMR.
No, I've got a mobile. It's,
No, you gotta have a mobile, you have a big.
There you go, mobile and HTs, or portable, as we call them. So some of the cons in my mind about DMR. The code plug. Everybody know what a code plug is? It's to strike fear into your heart.
Yeah, you just did.
Programming the radios is a bitch.
Without a computer, it's even worse.
Exactly. Oh yeah. Some of them don't even allow.
Computer absolutely necessary.
Yeah.
Absolutely.
So that's a con in my book.
Yes.
Audio quality versus other digital modes. And this is where the tomatoes could fly because this is subjective. DMR, to me, does sound very rich and deep. Low to mids, lows. I've heard more of that on DMR than any other mode. But I kind of feel it lacks the mids and the highs. That's just my ears. And anyway, it's very subjective. Yeah, you might mess up your hearing aid. Uncalibrated, cheap hotspots. A lot of people use hotspots to access the internet networks of DMR networks, which we'll talk about a little bit later. If you have a cheaper one and it's not calibrated, you're gonna hear crap a lot from digital modes. You got to be pretty much right on the money to some of these words in order for some of these modes to work properly. Especially with the time slots, the timing has to be perfect. So there are some things you can get out there that might be cheap, and you got to fool with it to get it to work right. And that frustrates people, and it'll prevent them. So that's a con.
That's why we got you.
There you go. Yeah, find
Find
your local people who have tortured themselves to figure it out. D-Star. D-Star is ICOM's money. That's their network. That's their modes for this. And again, pros, audio quality versus analog, same thing. It works over HF as well as VHF and UHF. My ICOM 9100 has D-Star built into it, and you can go anywhere in HF. One of the drawbacks, you've got to have an S8, S7 signal in order for that decode to work. They use, like the other radios used TDMA, they use FDMA, frequency domain multi-access system. So it's a little bit different frequency use or spectrum use, the mode. Quality radios, holy crap. Okay, ICOM's on the top end of quality when it comes to radios.
And don't they know about their price?
Yes, and you're gonna pay for it. They're proud of it. Established networks. D-Star has the US Trust System, Quadnet,
You got the experimental system.
XRFs.
XRF.
Exactly.
ESC.
There are more networks out there supporting people talking to other D-Star people, including ICOMs, or the American Trust System, US Trust, which is very functional. There's a data mode sub-channel within. ICOM put the voice part into a very small bandwidth, 6.25 kilohertz of bandwidth is only what the voice is traveling. There's another sub-carrier. Every time you talk D-Star, that's data. That means what? Voice and data at the same time, right? They use an FDMA, so they can shove some information in there, and more information than not.
Whether it be APRS signals so the other guy can see where you are,
Yep.
or DRAT.
Yes. We've held a simplex, 5-person simplex net once with DRATs running on our computers hooked to the D-Star radios via USB cables. And that signal, we were talking to each other, all in simplex, 5 people. while sending data, chat, and emails to each other at the same time. We're talking, nobody hears anything else. As you're talking, that data sub-channel is still going in the background. You can unkey and you watch the computer still sending data. And that's simplex. That's incredible to me. So they got something here. Dual band digital receive. Some of the new models, this is what's new. Some of these newer models, like the ID52, are, you know, all the other digital radios, you're only hearing one digital conversation. It's got an A and a B, but you're only hearing one at a time. Now they're doing both. You can listen to two digital conversations at the same time. That's different. So the ICOM is changing. Obviously, they have portable, mobile, and base models. 9700, 7100, ID52. That's their newest set of these things. So cons, understanding controls. The worst part about D-Star when you first start using it is trying to figure out where to put the damn G, where to put the codes. It's an 8-character thing. They've tried to make it easier in their radios by using DR mode, but it's still, you gotta adapt to it. It ain't adapting to you.
And the easiest thing now is to get on D-Star info, download the code plug.
Yep, it
and
puts
just
it in.
import it and you're done.
Yeah, they've got a website that has the entire nationwide network in it already, and these radios have more than enough data to capture the global, every station out there. So that's why you're paying, how much for that one? 600?
600.
Yeah. You need matching hardware for data modes. Everybody's seen maybe an advertisement that says, I can send you a picture. Here, I'm going to send you my picture. I'm in a hurricane zone, I'm going to send you this picture. Well, unless you have an ID52, you ain't getting that picture. So that's a con to me. It's not an open type thing.
It's not open forum.
You got to have icon to icon. Don't send a picture from Yaesu to icon. I don't know if they don't like each other or what.
Or vice versa, I take it.
Yeah.
They're each trying to set their own
Market.
kingdoms up.
It's market, yeah. They're fighting for market. Kenwood, ICOM, and Yaesu. Yep.
But Kenwood did put out a D-Star radio.
Yeah.
Yep.
For a while they did.
Yeah, they stopped. That's right.
It's pretty nice too.
Con Network Registration Fund. I've seen the Metairie-based registrar at this Hamfest today, John Britton. And I remember when I first got on that network, I was trying to figure out, what the hell do I have to do? I'm filling out a form at W5GAD's site, and I'm trying to figure out what's going on. So that was a learning curve, right up with trying to figure out how to make
Yeah,
my
I had to
9500.
email him because he hadn't checked the.
Yeah, that's what happened to me. I had to email that guy in Atlanta.
Yes.
Yeah.
That's why I started registering them through D-Star info.
Right. So now they've kind of, it's really us, the hams, who are taking that and making it work.
Trying to fix it.
Yes. HF, high signal level needed. We already discussed this. Unless you got an S8 or S9 or S7 on the HF side of D-Star, it ain't gonna decode it. There's a net every Sunday where they go over the entire country. KK4, I forget his name, but he's on.
They're trying to see where they can go and what the propagation is,
Yeah.
see what works and what doesn't work.
Right. It's challenging. System fusion, another C4FM is the mode here. Again, audio quality versus analog, still up there. I like their wide mode. That's intriguing to me. I think it's 12.5K wide of nothing but digital data, streaming with that voice. So you get some pretty good fidelity in there as compared to, let's say, ICOM 6.25. And they'll argue till the death on that. Definitely quality radios. Yaesu's another Japanese manufacturer who's doing it right. They just work. I've burned out several Oshans, Baofangs, and every other Chinese radio. Not a single Yaesu I've ever bought has failed me.
Where's wood when you need
It's
it?
just exploded. I know.
20 years ago, you couldn't have said that.
No, you're right there. It took them that long.
Yep.
It's gonna take Bofang and Wilson and all the rest of these. It'll take them a while, but they'll eventually get it right.
They'll get there.
Yeah.
Because
They're already better than
And
they
they'll
were.
steal it from everybody.
Oh, yeah.
Well, yeah.
Direct data capabilities, like I was saying before, pictures. If you got that full 100, You can send another person with a 400. I think, is it a camera that you
Yeah,
have
the
to get?
camera mic.
A mic. Yeah, there's a mic that you buy. And again, I think it's closed within their system. So I listed it as a pro here, but it's still a con too.
Still a con, yeah.
It's kind of only if you have those Yaesus are you going to do that.
And what you have to do if you got the other radio, you could still receive it, but then you gotta take the SD card out of the radio and stick it in
Yeah.
the computer to see it.
Yep, yep. Yeah, you're not
Right.
seeing. They also have, I think, I don't know if yours does this, Mike, but the simultaneous to multi-receiving 2 digital on the same.
The 300
Portable.
will do that.
Yeah,
The
300.
400 only
Top,
does
that
one
top.
side.
All it does
Not
one
bad
side.
on
Top
you.
over.
Okay.
400 does one side over.
See, so there you go, portable, mobile, and base models. That is, in my opinion, one of the best radios they've ever released.
Mm-hmm.
Yeah. It works pretty good.
FT991A.
Got it. The 991A.
Yeah, it's a shack in a box.
The regular 991 works too,
I've got
but
the
the
991, not the 8.
Ah,
spectrum display is just
Yeah.
a shot. It's
You
just
see, that's
a
'cause
shot.
you didn't get a good grade on your test.
all right, cons, uncertainty of network control. Now this is, let me explain that. Yaesu has a network. It's out of Japan. They control it. But there's been things going up in the air about it, like, we're going to sort of turn it off. And you know, everybody wants that market share, and that's one of the things they do. However, hams, in their infinite wisdom, we set up our own damn network. Shut up. YSF, here we are. We're using a whole different set of networks. But from the vendor, that's a con. Needs matching hardware for data modes, sending pictures to each other. Uncalibrated cheap hotspots. Here's another one where if you're using cheap hotspots,
eBay.
then you're going to wind up having to fiddle with it to get it to work just right.
You look at the bit error rate that it
Yeah.
says that
Yeah.
go and you tweak it a little bit to get it back to 0.
Yeah, it's like 5% sometimes.
Yeah, yeah.
And you see all these
R2D2.
people that have the bad packet loss when they talk, and that's what it's called.
That used to be me.
So here's a brand new one. I always want to cover something new in these forums. M17 is a mode that Ham started. It's definitely experimental still to this day. There is only 1 or 2 radios that you can put a firmware on that will use that protocol.
1.
1. 380,
TYT.
MD38
It's
TYT.
either the 380 or the 370. I don't
Yeah.
know.
So
One of the two.
you got to put a special, it's experimental. Now, why did I list that as a pro? Well, that's what hams do. What they're trying to overcome is the fact that ICOM is using those chips that cost $500, which is why their radio costs $500, and it's closed source. This is open source. And they're trying to develop it and network it. And I saw them at Huntsville, I saw them at Ohio. They are moving. They're actively developing this, and they're using that same codec that took the 1 or 2 kilohertz, very low bandwidth. However, it's on VHF, they're using higher rates. So
The only drawback is though, in order to do the M17, you have to open up the radio and take
yeah,
stuff off.
yeah, filtering, all of that stuff. They're hardware hacking and software hacking and protocol hacking and network hacking, and it's just hacking all around. It's a hack. That's a pro to me.
That's good.
Yeah.
I'll have trouble with that.
Cons, it's experimental. Well, look at that, same thing. You don't know what the hell you're going to get, but you know what? It's going to be fun trying, right? It is currently in development. Not many modes have it. I just saw, it's obscure, I just saw the Pi-Star image where you can modify it to use M17, convert from Yaesu, convert from another mode, DMR, to Yaesu. So people are trying to figure out the bridging, the networking, etc.
Yeah.
They'll get it figured out.
Yes, they will. And then finally, I think this is the last voice, maybe not. FreeDV is a software that is designed for HF using that low bandwidth. 1 kilohertz. 1 kilohertz of bandwidth, that's nothing. Most HF conversations on a single sideband take 3, you know, 2.8 or whatever we do. So this is a 1 kilohertz, and they claim it rivals. Same idea, no hiss in the background. We all know single sideband, ear fatigue, listening to that all day. And this is the digital mode. There's actually a network that'll let you browse, see the other people, almost like a chat, saying who's on it and who's listening on what frequency and where. This is pretty cool. So digital voice for HF. Everything else we've been talking about, except for D-Star, has been primarily VHF, UHF over repeaters, right, or simplex. This is HF, which means global communications. Cons, got to have an HF SSB radio. Anybody priced those lately? It's $500 to $10,000, right? So that's a con, a little bit. Although we're all hams. Computers with 2 sound cards. Well, most radios now have them built in, right? The USB port, like the FT991, has a sound card built into it. And you just plug it into the computer and it presents as a speaker and a microphone. And it uses audio frequency keying, AFSK. Right. So that is a con, because not too many people are going to dedicate a computer to just one mode to convert something they're already using. Probably successful anyway. It's also obscure. Not too many people are using it. And here's where I was going to get into the analog. All-Star, Echo Link, IRLP. Everybody heard of those? All-Stars use asterisk phone systems in the background to convert open source PBX, basically. Echo Link has its own proprietary or software system along with a bunch of conference servers. IRLP is Yaesu's original analog throw out to that system, back before digital. So why am I listening to this? You know, why am I listing this? Digital. What are you talking about, man? This is hybrid. You start off at FM, analog. You wind up hitting the Echo Link software either on a computer or some Kenwoods have it built in, sysop mode for control.
Phone, whatever, go straight.
Then what you said, you hit VoIP.
Yep.
It's converted to digital, hits the internet via voice over IP protocol, back to some other Echo Link on the other end, the far end, and then back to HF or FM or analog again. So the reason I listed this is digital. And there are issues and there are things you got to know about that. A lot of people get the audio parts of these messed up. It's too loud, too soft, too, it's not enough, whatever it is, it's messed up. We have an entire net on Tuesday nights dedicated to audio, checking the audio of all these different modes. It's called the sound check net. And there's one system in Ohio from Jeffrey, K8JTK, who literally set up an entire Amazon cloud server instances for every mode. And you can hit all of his IPs for every single mode. I mean every mode. He's got them all. So that's the analogs. This is the phone systems. There are EOCs in Louisiana, and I know Edward.
I've got one perched on the desk in my shack.
There you go. So we can talk to each other direct in some type of thing, only if that's available. So that's like a reoccurring theme in this entire presentation. If the net's there, use it. Use it. Less traffic on the RF to me. If it's not there, find something that already works, and this is not going to work. Unless you set up your own IP network, which you'll see later on networking. It's called mesh networking. So, VoIP phones, and yes, it does translate to RF. People can talk on there and wind up on the phone and vice versa. Still got to be a ham. Just to get this, you got to be a ham to join their network. So you on the ham hotline?
Huh?
The Ham Shack hotline?
Yeah.
Yeah. Got one at the EOC?
Got one for that's where this one tied directly to the EOC.
Exactly.
Are there any other people in here that are on Ham Shack hotline?
I saw one, I wanted to get one, but I need to figure out what hardware phone I need to get.
Very cheap. SP303 is like $10.
They probably got a pile of them.
You get those phones on eBay.
50 of them the other day, and I read it.
Give it
Giving
away.
away.
Please pick it
I'm
up.
getting it out of my closet.
That's pretty much exactly what they were saying. If they wouldn't have been in Texas, I'd have driven over for them.
So,
What's really nice about it too, like he said, you can actually go into some of the networks. They have repeaters hooked to the thing, and you can hit a button on the phone,
Oh, yeah.
talk into it, it comes out on the
Star
repeater.
99, yeah. Star 99 and pound, yep. That's right. You transmit, you're turning on the transmit of a remote radio. And then it's over RF. So anyway, All right, we're going to switch to the next topic, which is digital data. We've been talking about digital voice all this time. There's a lot of stuff out there. What about data? Packet, AX.25 is still out there. Technology, what's up, Irvin?
Hey, what's the Motorola?
What? I mean, this is from the 80s. 300 baud, 1200 baud. It's still relevant. I'm going to show you.
Yeah, there's an AEA PK2.
Yeah, you saw it on the table?
Jeff.
You can still find them.
Yep.
Vara is something that's new, which we'll talk about. Vara HF and Vara FM. It's kind of sweeping the IMCOM people right now. VAR AC is a software that uses Vara. WSGTX, everybody here is betcha familiar with FT8.
Yeah.
Yeah. Some people hate it, some people love it, and there's all sorts of other modes. It's a suite. But FT8, FT4, those are the most prevalent.
JT65,
Yeah.
there's another one, JT9, JT8.
JS8 call is something somebody decided to take their software, modify it, and turn it into a real HF relay store and forward system. That's impressive to me. I've used it, and a lot of people don't know about it. Pactor 1, 2, 3, and 4. Yeah, you better get your pocketbook out for these guys.
Everybody, we just blew a factor modem at the WP.
Ouch. Was it a Dragon?
Snapdragon. Snapdragon.
Yeah. I know what you're talking about. P4 Dragon.
P4 Dragon.
Yeah, that.
Only $1,600.
Exactly. $1,600 a pop. All it is the modem. But it's a very specific type of modem with the filters that are built in and hardware that'll just do it for you. Olivier is a kind of an old mode. Why would I list it here? You'll see.
That's multi-frequency, audio frequency.
AFSK.
Is that the one where you turn across the dial and it sounds like a flute?
Yep,
Yes.
that's the one.
If you even hear it, and it'll still decode even if you don't hear it.
Yeah.
That's why I listed it here. You'll see BPSK, PSK, MFSK, MT63, all digital mode examples. RTTY, DRM, I could go on forever here, DRATs, and SDR. So let's go packet. There is a main frequency for packet. If you've never heard it or you want to hear it, you can hold the thing up to the speaker and actually decode it on the computer. It's that sensitive or usable. 1200 baud. Welcome back. I just love the 80s. What else is out there? You know, there's mailboxes. You can leave messages for people.
Yep.
BBS systems, WinLink, email, gateways, chat point-to-point, hits, you name it. That's what I consider terminal mode, which you'll see in the next slide. APRS, Automatic Packet Reporting System, not position. And it also has similar functions, beacons, text gateways. You can text people via SMS networks straight from an APRS radio. Mic E statuses. That's the most unknown thing that I've ever seen people, but I've actually seen hams do it. You're basically saying, I'm at a special event. You're advertising to other hams that 1, I'm available, 2, here is my location, 3, this is what I'm doing. And it's a broadcast, beacon only. So it's one way, but all of a sudden you got this network out there that redistributes your packets either via the internet or RF, or both. So very functional if you use it. That same thing exists on HF, except it's not 1200 baud or 9600 like these can be. It's 300 baud. Yeah, you can almost decode it by ear, right? And it's very slow. This is not meant for big data. Nowhere near it. Text files, short messages, and that type. What's out there? Again, beacon, mailboxes, BBSs, chat, and point-to-point communications. I've seen those.
Commodore 64.
Yeah, it is the 80s all over again. I had all of them. VIC-20, 64, Amiga. You know, network one.
Trash Model 1.
Yeah, the
Yeah,
TRS.
that was it too,
I used to
yeah.
connect to the TRS
There was a
boards.
TI-99 4A that did it too.
Yeah. Network 105 is what it's called because it's on 14.105. They have a sideband. And a lot of people hang out, or not hang out, their machines are there. If the propagation's right, you're going to hit them. UHF, same thing as this guy, same protocol, just different rates. Anybody know why we have these limits? Why are we stuck in the 80s?
Because they work.
Anybody? Well, that's one thing, lowest common denominator, they just work, but there is a reason why we don't move beyond this.
Those are the speeds of the modems at the time.
FCC.
The FCC, you got it. They've limited our rates of symbols that we can send over network. They call it symbols. It's just ones and zeros that represent some character. They've limited the rate we can use on purpose. They are trying to make sure, remember, there's no security in ham radio. Zero. If you're looking for obscure or messaging security, get out of this.
Get out of it.
It's not for that. This is all about open, everybody can read it. You're helping somebody else, or you're trying.
No matter how obscure you get, somebody out there can read it.
That's right. So they're making sure with our symbol rates, other people won't use it and become a threat against encryption. You all know radios out there that can encrypt, so the internet. So what's the difference between when I said terminal mode and something else? What am I talking about? I'm talking about, like you said, there's a table out there that has a PK232 hardware piece of modem sitting there.
Yep.
These guys are great because they can work without a computer hooked to them. You can initially program.
Once you program it,
Forget it. Put it on the radio, put it at the tower site, bye. It's going to do what you tell it to do. Which most cases, these things are repeating, or something called a digipeater. They're repeating packets. All right. Then there is sound card. So when I say TNC, terminal node controllers, that's what these are called. Hardware modems is all it is. Versus sound card, where you got a computer hooked USB. This is the FT991. And
It looked familiar.
an antenna, right? So with that setup, you can accomplish the same things, exactly the same things as this, but you need that combination for it to work. This one, so there are advantages to having both, or one or the other. Something new on this front is there's a guy in California, what's this called, Glenn?
KM6LYW.
Yeah, KN6LYW, I didn't put it in there. He developed, you know we have hotspots for voice? You can connect all the modes over the internet. This guy invented a hotspot for data. So every single mode is available for data in a Raspberry Pi.
And we happen to have one in the wild.
We happen to have built one, Glenn and I. This is it. It's got some USB hubs and a display sitting on top of it. And you can actively control it from any web browser and switch between any of these
Or your
modes.
telephone.
Or a phone, yeah, or a mobile device. You can Bluetooth to it, Wi-Fi to it, whatever. And switch between all those different modes. Your radio is connecting to this, sending the data.
Plug it into the 991 and
Yeah.
go to town.
It is, so that got to hand it to this guy. He was thinking. He's like, hey, we got these voice hotspots. What about a data hotspot? Go look up DigiPi. That's awesome, what he's doing. It's something new. Vara HF, Vara FM. So there's a developer in South America, Venezuela. I don't know where he's from. I know it's South America
I
somewhere.
think it's from Venezuela.
Well, Spain is an EA5. I don't know. That call might tell us.
Yeah, that's
Yeah,
K5,
Spain.
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 Spain, yeah.
So you might, okay. So there's a person who invented this protocol, and it's pretty much taken off with WinLink. WinLink has it integrated into their protocols already. There are multiple protocols. And it's rivaling the speeds if you register it
the factor.
with Pactor 4. They won't let us do that, of course. You got to get a, in order to do Pactor 4 high speeds. But we normally don't, get to those levels actually because of HF conditions. Propagation, it won't negotiate that. You probably got to be close to each other to get the highest rate. But this is another mode that will work in very good or harsh signal-to-noise ratio conditions. Field day, winter field day, Glenn and I were in a field with a compromised antenna, that's what I call them. You ever see those MFJ antennas that are a bunch of coils with radials?
Is that big ears or whatever?
It's not the big ear, it's the other one that looks like a Christmas tree.
Oh, yeah.
And
yeah, cobweb.
We stuck that in the field, and we had this, by the way. It was using PAT, or in the WinLink networks.
Pat.
And we were trying to figure out if we could use this effectively, I could not hear the other station. I couldn't see it on the waterfall. The computer's decoded it. That's incredible to me. That's really good conditions. Or on a compromised setup, it just worked.
How did you know when you were on there?
You can see the information coming back from the protocol. This is a software TNC. Remember how we had hardware? There's the software. So you can see the data link established. It's an ALE type. It was established. I could not even see it, Rick, on the waterfall. It blew me away. But yet the computer was sitting there decoding.
You have to look at it on the computer as you adjust.
I think it was working like Olivia, that mode. They worked like 12 dB below the noise floor. You don't even see it, but it's there. So these guys are taking off, and they are also writing software, which you'll see a little bit.
Correct one thing though, the DigiPi does not have
Oh,
Vera on it.
that's right, that's
It's on your
right.
computer.
That's right. We were on my laptop using the Vera TNC.
Yeah.
That's right.
I use it with one link.
WinLink, exactly. It's built in. So they're also writing software. RAC, this is not the same company. This is another guy, I think from Israel, who is writing this software that is basically putting like a Teams chat or a Skype, if you're familiar with chatting, interface onto HF. And I don't just mean that in, oh, it's point to point, I'm going to see his text, keyboard to keyboard is what they call the mode. You're typing, you're chatting with someone. This one's a little different. You can see that he's typing, like it's sending this HF, it's a constant connection between the two stations and they constantly pull each other. And you can actually see when he's starting to type that, oh, he's typing, wait up, hold on. So he's implementing these modernized chat features that we're all using in the IT field into HF. HF communications over the air. I've talked to this guy directly over this mode. He's in Israel. Fuzzy1AC is the developer. And it's amazing. Because of the low signal to noise ratio characteristics, it just works. WSJTX, we're probably all familiar with FT8. This is a JT9 conversation down here. These guys decided to make a couple set of protocols that use time. The reason they're so good at long distance communications and contacts is because you haven't noticed it takes FT8 seconds to have a conversation, right? It's 8 seconds of AFSK, Rick, you mentioned it, where it's doing the beeps and the boops in the background. But if you slow that time down into seconds, your signal makes it further. Isn't that something? These guys realized that. Princeton University developed WSJTX Suite. Whisper being the most awesome. Have anybody ever used Whisper?
I know about it.
Yeah. Half a watt. And they're hearing you in Antarctica, Australia, and Japan. Half a watt. It takes 12 seconds for that conversation to be broadcasted out. Very low level.
The secret is that you gotta have the correct time on the computer.
Time
Timing is
synchronization.
critical.
Yeah, if you're
Yes,
more
it
than a
is.
second
Timing
off,
is
you're gonna have
critical.
trouble.
1 second off, and you're not going to decode.
Nope.
So you got to hit the NTP servers on the internet because they're doing it across the world. And some people have offset their time on purpose. I don't know if y'all have heard that. They do it. They mess it up just to get on a different time slot.
Like that one on below, the bottom one there, is 1.2.
Yeah, that's right. You can tell how far they're off and whether your computer will decode it. And there's a global network of instant PSK reporter, I think is what it is. It'll instantly give you feedback of who heard you all over the world.
That's a great problem.
Yes, yes it is. And they integrated it. It automatically uploads your transmissions and receipts to a database, which is instantly available globally. JSA call. Here's a situation where I think his name is Josh or Jason, I forget, but Jordan. Okay, and he modified that FT8 mode and turned it into a chat keyboard to keyboard like we used to do with PSK32 or 31. Sorry, yeah. And he turned it into a system that has some interesting capabilities. One of them being the ability, if I can't hear, you know how in packet you got a digipeater that can relay? You know, you broadcast it, but you're only putting out 5 watts. There's a repeater sitting up at 630 feet here in Slidell that can send it out 70 miles from here via VHF.
Anybody within a 70-mile radius can go.
Then they can jump it. Exactly. That's right. In fact, our network covers from Baton Rouge to Gulfport or Biloxi.
I did it from Tupelo, Mississippi to Des Allemands, Louisiana.
There you go.
A number of occasions, just link to the next digit.
That's right.
Top of the chain.
So this is the same way. He wrote into his software that you can leave your computer on with HF on these frequencies. And then if someone can't hear you 1,200 miles away, but someone can 600 miles away, it's going to relay that message. You can see that that other station is available via a network database he set up, and it knows how to route that message. That's pretty intelligent use of the internet if it's there. If it's not, it's still going to work. No. In this case, you're going to have a network of hams computers who exchange that information about the database over the air. That's smart thinking. This guy's put his thinking cap on. He's given some presentations that I've seen personally, which is awesome. KE5QKR, Jordan. Pack toy.
Yeah.
And there you go. There's the $1,600 burnt toast. This guy, the P4 Dragon, is probably used just about on every maritime ship out there. Why? Because they're in the middle of nowhere and they need to get a message out. Whether it's distress or just regular traffic, weather information, you name it. This is the hardware standard of the day. It just works and it's high speed. It'll figure out for you which channels of propagations are available and keep that in itself. What is that called? ALE? There's a military standard for it too, which you'll see a little bit later. ARQ and ALE standards are in this thing. So this is an awesome radio with filters built in to do the job. But boy, you're gonna pay for it. A lot of hams don't want to spend $1,600 on a modem.
Well, in my case, it's the EOC that uses it.
Exactly.
We
Life or
use
death.
it to be able to contact GOSEP in Baton Rouge. But also, if we can't get Baton Rouge, we can use it to go to
Out.
Puerto Rico.
Yes.
And then Puerto Rico's got a hardware link back to
Exactly.
Baton Rouge or wherever we need that email to go.
This guy's experienced. I'm just going to tell you, I've never met you before, but I'm going to tell you right now. You got in a tactical situation, you got to figure out how to get your message out so it can come back in. I know that sounds weird, but when you start looking at how they use systems like these, that's it in a nutshell. This gives us method. So this is also life and death. The reason they have them on ships is because it's required. They wouldn't buy them unless they were telling you have to have this on board for lives and souls.
So, safety of life at sea.
There you go. FL Digi, probably everybody's heard of FL Digi by now. Linux distributions and Windows and all kind of other things. And holy crap, look at all the digital modes.
Yeah.
Jeez, this thing, they have modes in here I've just never heard of.
Yeah.
The APSK modes and
The biggest problem with having that many things is you gotta make sure the guy on the other end knows that that's what you're gonna
it's
do.
coming. It's coming. Wait, that's in the presentation. So FL Digi's been out there for a long while, and it's a suite of software written by, I think, a French person.
Does that say hell?
Yes.
Yeah.
Yes, Hell is
Hell.
Yeah, there is
Hell
no
Striver.
Hell Striver, yeah.
Subscriber.
It's hell. There it is. If you want to go to hell. I'm waiting for the handbasket mode to come out. But anyway, FL Digi's out there. It's been out there forever. And they develop it, they keep it up. It's got ring control, it's got all of these things. NBEMS, a lot of INCOM people latch on to NBEMS messaging with the forms. All the forms are built in for ARRL. It's really something. The interface, a little quirky because it was written in different languages.
It's a little bit of a kludge.
Yes, and it works between Linux or Windows, so that's why the interface is ported and is written in a foreign country, but it works. If you spend the time with it, it's just going to work. Okay. Digital imaging. Now, some of the stuff I have on this slide is not digital. But I had to show it because it was Halloween, for one. But two, you see this image right here was actually posted to a waterfall. You know how all these radios now are coming with the waterfall displays and SDR receivers? You get that waterfall. People are printing images and data and text on the waterfall, just using audio keying. Isn't that something? So there's a whole network of people out there who are pasting stuff onto waterfalls that people can decode. You wouldn't think of it. If you're trying to decode this digitally, you won't know what the hell is going on until you look at the waterfall and see, he just drew a damn picture on the waterfall.
Something with too much time underneath.
Yeah.
That's like ASCII imaging.
It is. You remember ASCII art?
Yep.
Yeah. Now, there are images out there, this one's analog, that are, like this one came from the ISS. Occasionally, they'll pass over and send slow scan television for you to receive that image off their transponders. There are softwares out there, the EasyPal, that will send images digitally. Using, I think,
You got
DRM.
STTV on both the DigiPi and the Build-A-Pi suite.
Yeah.
Linux on the Raspberry Pis.
So I thought that was neat. The reason I listed this is because these waterfalls are actually digitized audio that's over time, right? It's kind of like watching the spectrum. So anyway, DRATs. A lot of people don't know what DRATs is, but it's out there, and it's been out there, like since 2007 or some ridiculous amount of time. The developer who made this, it is a D-Star. Remember I told you about that sub-channel protocol or data channel within D-Star? It can send emails, instant messages, beacons. You can transfer binary files between radios, structured forms, GPS positions, you name it. And of course it hooks to the internet. Well, it just so happens that one of these, St. Tammany, Louisiana, sttammany.reflector.com, from Buckland. He is a reflector, a DRATS reflector. You have voice reflectors, you also have data reflectors. So imagine conference rooms set up specifically for exchanging data, files over the radio. That's a good thing to have in your toolbox.
One of the things that hampered DRATs is that the original author stopped upgrading the thing, and other people like WinLink started requiring passwords and stuff, so basically it broke it.
Yeah.
Two guys in Europe got together, got Dan Smith's permission to refinagle the thing, and it's all working again now.
Yeah. There's some development happening on the new versions of DRATs. So this is out there as a D-Star tool for people who want to exchange data between D-Star systems.
They also draw maps that
Yeah.
like APRS and tell you where all these stations are.
That's right. GPS position reports are a part of it, integral. You just got to load the maps. I didn't capture that. But very functional software. And kind of obscure. A lot of people don't use it, but it's out there and it works.
It's interesting.
Is
that
D still
the
spelled
DRATs is backwards star.
Right.
Yeah.
Is it? That's right. What were you saying?
No, that was me.
No,
I
that
said
was-
D still spelled backwards. It's the same thing.
Yeah,
you
yeah,
said,
yeah, okay. Yes, it is. So SDRs, this is the digital aspect of data, because what's happening with all these guys, well, ICON calls it direct sampling. You're literally sampling the IF coming into the antenna and then slicing it up into pieces that you want to listen to digitally, which means the software is deciding how you can filter. And let me tell you, with a digital filter, you can pretty much get it down to one bit or one thing. It's crazy amounts of filters, not that you'd ever use that.
Yeah.
Flex is virtualizing slices. In this radio, you actually have 8 radios. So all they're doing is the VMware part of radio. They're slicing up and digitizing the incoming IF, RF, and then giving it to 4 different radios that are built into that. slices. They call it slices in Flex. Okay, you better get your pocketbook out for one of those too. You heard David
Yeah.
earlier,
Well, it used to be 2 grand, I
$13,000.
don't know how much it is anymore.
Yeah,
Probably more.
he's got 13 grand of radio that he's
Yeah.
protecting with that
Yeah.
lightning thing he showed us. But you don't have to spend 13 grand. You could spend 200 and get this guy, which is a dual receiver that covers the entire HF spectrum, all the way up to VHF and UHF as well. And you can look at about 7 megahertz at a time, which is a big pan adapter. All these signals you've seen. You can watch the entire band at once. So you see all signals, and if you want to hear the signal instead of turning the VFO, you click on it with a mouse. Done.
That's receive only.
That's receive. Yeah, the Flex is a transceiver with that idea in mind. This is a receiver only. And these little dongles you can get for 20 bucks do the same thing. They were originally satellite receivers in Europe, the DAB networks, television, and they said, we can convert this up to 1.2 gigs for 20 bucks. So Yaesu's newest FT710 is also an SDR radio. Also direct conversion or direct sampling of the RF coming in and then slicing it up. So that's digital on a different level. It's not necessarily geared towards data, but it takes, these things are damn computers. They're not radios, they're computers. So that's the digital data part of that. You can output that data and do whatever you want with it. Imagine that capability. But you can automate, I'm sure there's somewhere in an FCC monitoring station somewhere in the government, something capturing everything we're doing in real time, and they can play it
I
back later.
refuse to say anything in the garbage incinerator.
I refuse to confirm or deny that.
If we have this technology, what do they have? Think about it. All right.
Oh, what,
They catch us very quickly if they don't.
no,
What time is it?
trust me, it's almost noon.
3 minutes
Foretell.
as well.
Yeah.
That's the next one?
11:56.
So just 3 minutes for the whole thing left?
Yeah, you'd have to look at the thing. I think they
Okay.
might have had a break.
Yeah, there's supposed to be like a 30 or 45-minute break.
Okay.
Yeah, they don't, ARRL doesn't come in until 1.
All right, I'll quickly go through the networks. The networking part of this is what's behind D-Star, Yaesu System Fusion, DMR, all the modes we've talked about, plus some we haven't talked about. So D-Star has the US Trust. Imagine this as being the network on the internet that allows these repeaters to talk to each other, link with each other, and find each other online. That's all that is. This is the networking of all these modes. Why can we talk to Alabama and California from our repeater here in Slidell? Because these networks exist out there. People are linking themselves together with control systems. YSF, FCS, WiresX, IMRS. Those are all Yaesu networks. This is the one that I was telling you is the control is a little flaky, but it's still out there. They keep it up pretty good.
Yeah, there's one out on the table out there, I saw that too.
Oh, the HRI boxes?
HRI, yeah.
Yeah, Glenn.
That's Russ's D-Born.
Okay, the Warren network
Got
is,
the thing up.
yeah. There's a network here on the
The
table. out
D-Born
there.
room, we have repeaters all over the state of Louisiana right now that are linking together in D-Born.
Yeah.
Monroe,
Farrell's into that too.
Shreveport.
Yes,
Baton
I talk to
Rouge.
Farrell all the time on it. Brandmeister for DMR, TGIF. This is an awesome, I don't know if everybody's ever used their dashboard for DMR. That thing is freaking awesome. You can listen to every channel on the computer. You can control your radio through the website back to your radio. It's crazy.
And if you're on a hotspot, some stuff from there is mandatory.
Yeah, it'll control it. There's passwords and all kind of. NXDN, P25, and M17, they all have their own networks that are out there. People are trying to put together commercial systems, in fact, with these networks. I think the hams are kind of, companies have their own networks, WANs, LANs, and MANs, right? But radio systems are integrated into those. Right. Consolidated, just like the phone systems did. So, then there is networking in its purest form. IP networking, internet protocol that can be point to point and not connected to the internet. Of course, if the internet's there, use it. If it's not, put up your own network. There are cities in Arizona, Dallas, I want to say, and other places that are using these ubiquity dishes, point-to-point networks, setting up their own IP backbones because they're expecting the other one to go down. Or cell networks not to work.
California.
Yeah, they're, Dallas Fort Worth has them too.
There are some extreme limitations on these, however, because you cannot obfuscate data. So HTTPS, out, right? You're not going to do a TLS encrypted web service over this system because you can't.
The other drawback too is you gotta get the antennas at height,
Yeah,
They have to be at
which
height.
almost negates
right
it
edge.
down here because the trees
Fresnel,
tear it up.
yeah, microwave and Fresnel zones, there's all kind of engineering behind this crap. That 105 network we talked about, it is an actual network of servers that are always there that can listen for data traffic over that packet type system. There's a guy in the Ukraine, UZ7HO, who has a software out there called Sound Modem. Okay? We were talking about those hardwares that have the USB connector in the back, presents as a sound card. There's no beating that software. It's free and it does work. It's a TNC, a software TNC, instead of those hardware ones we looked at. And that's what that's all about.
He's actually got two, one's called sound modem and the other one's HS.
Yeah,
sound modem.
high speed.
That's for HF.
Yep, high-speed sound modems. And he also has some checkers and chess games that you can play over the air. Radio to radio. Yeah. APRS. Data for APRS. Anybody ever notice when they look on the map, they see our club, the WinLink gateways that are in our area, some weather stations, Glenn's station, his D-Star hotspot is online. That data is coming from, in this case, that's my WinLink gateway. That actually comes from WinLink. They post that there's a service available in your area. What this is for is when people are driving through your area, they want to know what's around. They don't have to key up or hit a repeater. You can look here and see what's around and who's around and maybe what they're doing if they publish that information. So there's all sorts of things here that are in place. Somebody's driving, the 85TC was driving when I caught this picture, and a couple other cars that are actually in motion. You can see it tracks, and you can tell it how far you want to track motion if they decide to give that information out. So there's an entire data network behind APRS. APRS was designed to work radio only, but there's an IS, the internet service of APRS, where you can publish it to a central database. And then it'll display on services like this, which is APRS.5.
You know why he invented that?
Positioning.
Bob Brenninger. He was the satellite instructor for the Navy. So
Ship
the
position.
Army-Navy game, they always, they run the football. There's a marathon where they're running the football,
Yep.
the game ball.
Yep.
He wanted to track that, so he invented this system.
That's cool.
And then he also wanted another way to send messages from like submarines and
Nice.
stuff. So,
Thanks, Irvin. Man, that's no doubt. People have some time on their hands.
yeah.
Camille, about APRS,
Well,
it's not just positioning.
right.
You can
Right.
also send text messages, send
Right.
stuff
Right.
into the SMS.
Weather.
You can send status information.
You
Right.
can,
Mikey status.
Well,
You can
APRS
actually
is
send
not-
text messages out and
Exactly, as
Yeah.
SMS gateways. That, yep, that was all listed on that.
There's a gateway on the International Space Station.
Yes, there is.
You can send APRS right through the space station.
Who knew there was an entire range of internet block addresses, the entire 44 block, dedicated to ham radio on the internet?
Yeah.
Yes, the entire 44 block is dedicated to ham radio from the 80s.
/8, yeah.
Gotta love the 80s. So it's called AmperNet, and I think there's another group that's managing them now. It's giving out all kinds of grants for radio lately. Like they're giving out $90,000 grant. Anyway, there's this whole organization here that you can use it over the air IP. Right. So, WinLink. WinLink is an entire network, global network of stations on 1, 2, 3, 4, 5, 6, way more protocols. So imagine a network of computers via multi-protocol, listening on multiple sets of frequencies, HF, VHF, UHF, that are global and they're always there. and it's tied to a backbone that's in AWS that is global, that all point to each other for redundancy, HA backbone. That's what WinLink is. Simply an email system over network, plus positioning, plus a whole bunch of other tools that people are using for IMCOM mainly.
I will say this much. A lot of this, when we use the WinLink as an emergency tool, do not send emails that are generated by people.
No.
Because what they're gonna do is they're gonna generate it as an attachment,
Yes.
and to make sure that everybody can read the attachment,
Yeah.
they put it in, wait for it, PDF format.
Yeah. It is, again, we're talking about
And
1200 baud, 300 baud transfer.
Correct.
You don't want to mess with data, pictures. It's short text in any format of an email.
But
Yeah.
what we wound up doing, my wife that was in here earlier, sat down and wrote out basic text versions of the ICS message logs.
Yeah. There you go, efficient transfer.
And all you do is you fill it out, tick, 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 and then you can put it, you can paste it in the body of the email,
Yeah.
send it.
Efficiency.
You don't have to worry about attachments or any of the rest of this. And it goes a lot faster, your messages get through with a
Agreed.
lot higher degree of reliability.
1K versus a half a K, yeah. Or versus 8K, which, yeah. This is, I think we talked about this earlier, the ALE standard. There's some modems out there and data that will track of which channels are open, propagation. It basically monitors propagation on its own to see if I'm going to get a message through to the other side, so that when you're ready to use it, it knows exactly where to use it online, and it's going to establish that link. So there are some military standards for that, and there's ham use of that as well, depending on what hardware you have or software. So another part of digital data, and knowing which channels and links you could establish with each other is really important. Otherwise, you got to try it. It takes a lot of time. These things keep it up for you. So the challenges. Somebody mentioned this, I think, maybe Glenn. Choosing one of these. It's not any good if we're all using different protocols trying to talk to each other. We got to pick one as a ham group and say, this works in my condition, this works in this scenario, let's use this one.
In Louisiana, during the storms, the governor wants us using
WinLink, exactly.
Yeah.
So knowing what works and having that is very important, and that was
One of the other things
challenges.
I will highly recommend is have a backup plan. You mentioned this earlier. If something don't happen, the frequency you're going to be using is either jammed up with man-made noise,
Yeah,
or we've got solar flare activity.
it's not happening, that's right, the propagation's not there.
The propagation is not there. Have a backup plan. Have a primary, a secondary, a tertiary, a quaternary backup plan, because it's got to do. Yes.
And practice. So use it, try to make sure it's there. This is my favorite one, especially in high T. Herding the cats, do we have a plan? Is that plan published? Does anybody even know about it? Or is it just a few people doing this thing and those people doing that thing? That's going to happen. But that is one of the challenges of making this stuff work for us. Herding the cats. I call it networking of people. I think I taught you this.
Yeah.
It's not just equipment. It's those people who are trying to use. Are we on the same page or not? Or
In the same book.
right.
Same chapter and all
Same
that.
book,
Same book.
Same book.
So what do we have? W5SLA, this Hamfest. We got a bunch of stuff out there. Thanks to people like Dave, K5OZ, Glenn, myself, and others that are in this club doing all kind of stuff. There are digital analog. Every one of our analog repeaters is doing something digital with a Pi Star image. DMR, Yaesu System Fusion, WiresX, and D-Star. All on different repeaters. All of them up there at 630 feet. We reach New Orleans. I know on the 2.7, which is a DMR repeater and an F1 repeater.
2.7 goes all the way to Port Allen.
Yeah.
It goes from Walker.
Yeah. Yep. And the coast too. So, and there's also a digipeater, right? We have a digipeater, and I always put this slide out here in our QRM to let people know. I can connect from my house with a 5-watt radio and a magnet mount on my shack tin roof. I can connect all the way through the Baton Rouge KE5QKR or wherever that's at. Also in New Orleans, there's a bulletin board service like in the 80s. That is sitting there. The Cellcom group, I think, runs it, Mike, and those guys. And then Hammond, WB5NED, has mailboxes along with us. We have mailboxes here where you can leave a message, just store it forward, or actually just store. Somebody else has got to come get it. But those are mailboxes. And then there's the WinLink system. Within my area, within a 250-mile area, 5, 6, 7, 8, 9, 10, there's a dozen plus gateways that I can hit via VHF, not to mention HF. So that is incredible to me. All this available from that one little radio sitting up there because of guys like him making it work. And that's it.
And thank you.
Digital hams. All right. Any questions or any comments or whatever? You let me know. You know how to get here. On the radio.
We know where you at.
We got ways of finding you.
Larry knows where I live.
Yeah. If you don't know where he lives at, find out.
You'll probably be on the air on Temperature Logic next week.
Tyler knows where I work, so I'm in trouble.
Yeah, but mainly you work at home though.
That's very good. Good point.
Hey, I wasn't gonna tell you secrets.